So we want to go ahead and convert these into Hindu Arabic numerals to our system. Okay, so the one thing we need to make note of is that, you know, what these symbols mean. So we've already been given that information. So we know that this one stands for 10, and this one here stands for a 1. The other thing we need to know is the base. So the Babylonian system was base 60, or is base 60. They also use a position. So I'm actually going to go ahead and start with number 7 because it's got a little bit more meat to it. So when I look at number 7, I said, all right, so I've got, this is one digit, and this one here represents another, or a place, a number place. So this one here, I've got these two, so that's going to be 10 plus a 1. So this is a 21. And the other one here, I've got 2 1s. So 1 plus 1, this position has a 2 in it. And again, I'm converting to base 60. So remember, we start with, 60 to the 0, and then 60 to the first, and so forth. 60 to the squared, 60 to the third, and so forth. So this is going to be the 60 to the 0 place, and this will be 60 to the first place. So now what I need to do is multiply and add these out. So I have 21 times 60 to the first plus 2 times 60 to the 0. Now remember, anything to the 0 power is going to be a 1. So 21 times 60, I get 1,260. And then 2 times 1 is 2. So this number is going to be 1,262. Okay. Now up here, I've got just the one position. So again, when I take all these, I need to add them together. So I have 2 of these. So I've got 10 plus 10. And then 3 of these, so plus 1, plus 1, no, plus 1. So I get a 23. And again, this is in the 1 spot. This is in the 60 to the 0 spot. So 23 times 60 to the 0, which is just a 1, is going to be 23. Okay, so this number here represents 23. For number 12, we're asked to write the counting numbers that are just before and just after the given number here. So before we do that, let me go ahead and talk a little bit about, counting. So like when we count, in our system, as you know, we got 1, 2, 3, 4, 5, we got 7, 8, 9, and then we run out of single digits. So the next one we said is 10, 1, 0, 1, 1, 1, 2, and so forth. So when we get up to 9, we stop. We don't have any more unique digits. So we have to start using 2 digits to represent our numbers. Well, it's the same thing with other bases. So again, in base 10, our digits are 0, 1, 2, all the way up through 9, and then we stop. If I am in base 5, then the only digits I can use are 0, 1, 2, 3, and 4. Once I get to 4, I stop. I no longer have, a single digit that'll represent a number, a numeral. I have to start using 2 digits. So when I'm counting in base 5, it'll be 0, 1, 2, 3, 4. I don't have a 5. So what comes next? 1, 0, 1, 1, 1, 2, 1, 3, 1, 4. And again, I don't have a 1, 5. The next one after that is going to be, think of it as you carry over. So you get 2, 0, then 2, 1, and so forth. Okay, so let's go up here to base 7. So for base 7, again, the numerals that I can use are 0, 1, 2, 3, 4, 5, and 6. That's it. I cannot use 7 or 8 or 9. Those don't exist in base 7. So here I have the number 3, 2, 4, 6 in base 7. Well, the number beforehand, that's an easy one. That's 3, 2, 4, 5. We just subtract 1. The problem is the number afterwards. I get 3, 2, 4, 7. And like I said, we cannot have a 7. So what happens to that 7? It's replaced with, not 1, 0, but it's kind of like replaced with a 1, 0. So this becomes like a 0, and we got to carry over the 1 there. So we get 3, 2, 5, 0. Base 7. Okay. So when you're using other bases, most important thing is to keep in mind which digits you have, which numerals exist in that base. And then anything outside of that, so in this case here, a 7, 8, or 9, I can't use those. I have to figure out how to replace them with the numbers that are in the system. Okay, and we'll get to more of that when we start adding and subtracting. Convert the numeral to a numeral in base 10. Okay, so when you're converting between bases, we're always going to end up either multiplying or divide. Okay, so when you're going into base 10, that's the one that we're familiar with. That's the one that's easier for us. And so we're going to be multiplying. Multiplying is easier than dividing. So I kind of put those two together. And one thing I want you to kind of think about with the base 10 system, when I had the numbers 6, 7, 8, 4, and this is in our system, base 10. Base 10. This is our one spot. That's, our tens. That's the hundreds. That's the thousands. So get the ones, tens, hundreds, and the thousands. Another way of writing these is to say that's 10 to the third. That is 10 squared. That is 10 to the first, and that is 10 to the 0 power. Well, the same thing's going to go for other bases. The only difference is my base won't be 10. It'll be base 8 or base 5, or in this case, base 6. Okay. So I'm going to take my number and write it out similarly. So again, this is my one spot. So this is 6 to the 0. This will be 6 to the first. This will be 6 squared. And this one will be 6 to the third power. So now I have 3 times 6 to the third plus, and then we have 2 times 6 squared plus 0 times 6 to the first plus 5 times 6 to the 0. I need to multiply out each one of these and then add them together. So this first one here, I would use 6 to the third power first. So we're going to get 3 times 216. So I'm going to get 648 plus, and then 2 times 72. So I get, 2 times 36. Flip it ahead. That's 32. 0 times anything is 0. And then again, recall that, don't forget that 6 to the 0 power is a 1. So 5 times 1 is 5. Adding these together, I get 725. And this is the number in base 10. Number 19, we're going to convert the decimal number to the given base. So now we're in base 10, and we want to go into some other base. In this case here, base 16. So when you are moving, like I said, with all of these, it's either going to be multiplying or dividing. And since this time we're going from base 10 into the unfamiliar base, that's one's going to be harder. It's not really harder, but I think of dividing as being harder, or we're going to something that's unfamiliar. So in this case here, our process is to go ahead and divide. So there are 2 basic methods that you can use when dividing. Both of them you have to keep track of. Both of them are going to divide repeatedly. So on one of them you kind of keep track of the divisors, and the other one you keep track of the remainders. I don't care which method you use, but I would just pick one and stick with it. So my first method, I'm going to go ahead and show you. In this one here, all we're going to do is divide by 16 and keep track of our divisors. So I'm going to start with 16, dividing into 6,784. So that'll go into, this is when you use your calculator. So 6,784 divided by 16, it's going to go in there 424 times. And then I multiply, it actually goes in there evenly. So I get 6,784, I subtract that, boom, my remainder is a 0. Now I'm going to divide again. 16 goes into, and I'm going to divide into this number up here. So that's what's going to come over here. So 16 into 424. So I use my calculator, I'll go into there 26 times. I am going to have a remainder, so I multiply 26 by 16. I get 416. And that will leave me with a remainder of 8. I keep going. So again, this number here is going to be the next one. So I take 16 into 26. So it'll go into there once. That'll give me a 16. Then I subtract. That leaves me with a remainder of 10. I keep going. You keep going until you hit 0. So now I got 16 into 1. Well, that'll go into there 0 times. This tells me that this is going to be my last round. So 0 times 16 is 0, and my remainder is 1. So I'm going to stop here. Okay, my answer is going to be the remainders, but in the reverse order. So it's going to be 1, 10, 8, and 0. Now I have an issue with this numeral 10 because you don't have, you can't use 1, 0 to represent it. That would look like something different. So how do I represent 10 as a single digit? We have to go over to the alphabet. So once you run out of numbers, 7, 8, 9, 10, 11, 12, 13, these are all, these exist in base 16. So once I get up to 10, I run out of numbers, so I start using letters. So this will be A, this will be B, C, D, and so forth. So the numeral, or the digit 10 has to be replaced with an A. So this is equal to 1, A, 8, 0 in base 16. And so that's my answer. I did say I would show you both ways, so let me come over here and let me carve out a little space here to show you the other method. Okay, the other method says let's go ahead and write this with our bases. What is, I got 16 to the 0, that's my 1 spot, my 1 spot, my 16 spot, my 10 spot. I get 16 squared, 16 to the third, and so forth, So multiplying these out, because I don't know where I need to go. So 16 to the 0 is a 1. 16 to the first is 16. That'll go into my original number. That's what I'm looking at. How will it go into this number? Okay. 16 squared is 256. Well, that'll go into there clearly. So 16 to the third, now I use my calculator, I get 4,096. Oh, that'll go into 6,000. All right, so what about 16 to the fourth power? Well, 16 to the fourth power is 65,536. Whoa, that one's too big. That's not going to divide into 6,784. So we're going to stop there. So I'm going to start with 16 to the third. So then I ask myself, how many times will that divide into there? So we'll go ahead and we'll start with 16 to the third. So 4,096. That'll go into here once. And then when I subtract, I am left with 2,688. Okay, so how many times will, now I go to the next one, so I did this one. So now how many times will 256 divide into 2,688? Well, that'll go into there 10 times. So 2,560, and that'll leave me with a remainder of 128. Keep going. So I used that one. Now 16 to the first. So how many times will 16 divide into 128? It'll go into there 8 times. And 16 times 128 is 128. My remainder is 0. And then one more time, how many times will 16 go into 0? It'll go into there 0 times. Okay, now I stop. So my answer is going to go ahead and be these divisors. These quotients here. So I got 1, 10, 8, and 0. Same thing we had before. 1, 10, 8, and 0. And again, 10 has to be replaced with the A. So we have 1, A, 8, 0 in base 16. So use whichever method you're comfortable with. It's completely up to you. And then also don't forget, if you have a base that's greater than base 10, don't be surprised if you get letters. And so we'll use those for anything that's more than one digit. So 1, 0, 1, 1, 1, 2, and so forth. Number 20, we're asked to convert 303 in base 4 into base 8. This is really a two-step process. Okay, so we're not going to go directly from base 4 into base 8. We're going to have to go from base 4 into base 10, and then from base 10 into base 8. So we're going to have to do both of them. Okay, so the first thing I have to do is go ahead and convert 303 base 4 into base 10. So I got 303 base 4. So again, this is going to be 4 to the 0 power. This will be 4 to the 1, and this will be 4 squared. So I've got 3 times 4 squared plus 0 times 4 to the first plus 3 times 4 to the 0. So I have 3 times 16, that's going to give me 48, plus, and then 0 times 4, that's going to be a 0, plus, and then this last one, remember 4 to the 0 is a 1, so 3 times 1 is 3. And so this is going to give me 51 in base 10. Okay, so we're halfway there. Now I got to go ahead and convert 51 in base 10 into base 8. So for this process, we're going to divide. Okay, and again, you can use either method. So I'm going to go ahead and go with the first method because I don't have to list out my bases. I don't have to figure out where to start. I just start dividing by 8. So how many times will 8 divide into 51? It'll go into there 6 times. So 6 times 8 is 48. I subtract and I get a remainder of 3. Remember, we're keeping track of our remainders. Okay, repeat. So now the question is, how many times will 8 go into 6? Well, it won't go in there at all. It goes in there 0 times. And 0 times 8 is 0, and I'm left over with 6. And again, once it goes in there 0 times, that tells you, we can stop. And then my answer is going to be the remainders, like I said, in the reverse order. So 6, 3, and base 8. And that's my final answer. Okay. So again, I converted from base 4 to base 10 by multiplying, and then I went from base 10 to base 8 using division algorithm. Add the 2 indicated bases. Okay, so adding another bases. Just like I said, we're going to talk a little bit about base 10. When I have 9 plus 7, I get a 16. So we said, well, you get just a 16. But what happens if I have, 19 plus 7? Well, then the 9 plus 7 is 16. So I bring down at 6 and I carry over the 1. And then I have 1 plus 1 is 2. So my answer is 26. We need to do the same thing on other bases. Okay, so if I have 0 plus 1 in base 2, that's just going to be a 1. No problem there. Well, same thing, I should do 0 plus 0. 0 plus 0, and it's going to be a 0. Okay, but what happens if I have 1 plus 1? 1 plus 1 is a 2. But in base 2, we don't have a 2 number. We only have a 0 and a 1, so I can't use that. What do I use instead? Well, 2 becomes, you bring down the 0 and you carry the 1. It becomes the number 1, 0. Another way of looking at it is to say, well, how do I write, 2 using only 0s and 1s? So I can look at how else can I write this with, base 2. So remember, if we were expanding it, we would have something times 2 to the first plus something times 2 to the 0 or times 1. I'd say, well, I need 1, 2, and then I need no extras because that'll give me a 2 plus 0, which is 2. Now let me go ahead and do the number 3. What happened with the number 3? So what's 3 equal to? Again, I think of it as saying, well, there's a 2 goes into there once, so one group of 2 comes out, and then my remainder is a 1. So I got 1 left over. It could be written as 1, 1. And if you prefer to, think of it like we did up here, we would say, okay, I get something times 2 to the first plus something times 2 to the 0. So how many 2's go into there? Only 1 2 goes into there. What's my remainder? 1's remainder. So again, this is 1 times 2 plus 1 times 1. And that's how I get my 3. Okay, so again, we have that same idea about, carrying over. All right, so let's look at the example we have here at hand. I'm going to write this out a little bit bigger. So I got 1, 1, 0, and then I've got 1, 1. Okay, so 0 plus 1 is a 1. There's no issue there. For the next 2 digits, I got 1 plus 1. Well, 1 plus 1 is a 2. But like I said, I can't use a 2. So what does 2 replace with? Well, that's, one group of 2 and 0 left over. So I'll give me the 0 and carry the 1. And now I have 1 plus 1 again. So 1 plus 1 is a 2. And the same thing happens. I cannot have a 2, so it's replaced with a 1, 0. So my final answer is going to be 1, 0, 0, 1. And this is in base 2. So when I ask you to go ahead and add in another base, I'm looking for this process. I want to see that you are carrying over. I don't want you to convert it to base 10, add them, and then convert the answer back. I want you to do the addition in base 10. And then the other thing you really got to watch out for is, remember, if it's base 2, what numbers can you use? Only 0 and 1. So if you end up with an answer that has a 2 or 3 in it, you should know that you're wrong and stop yourself right there. Even if you told me you know this is wrong, that's better than just going on and not even recognizing there's an error. Okay, we'll do some more of these. And number 23, we've got base 7. So we're going to be adding two numbers together in base 7. Okay, so again, let's just talk about, base 7 a little bit. I can have the digits 0, 1, 2, 3, 4, 5, 6. I'll just write them out. 2, 3, 4, 5, and 6. That's it. So anything over 6, I got to kick out. Okay, so 6 in base 7 is just going to be 6 in base 7. What about a 9? How would I write 9 in base 7? Okay, so since it's greater than 7, it's, I gotta think of a way of rewriting it. So again, one way of doing it is to say, well, 7 will go into 9 once, and the remainder is 2. So 9 in base 7 is written as 1, 2. And again, to check it, you would say, 1 times 7 to the first plus 2 times 7 to the 0 times 1. So that's 7 plus 2. Oh yeah, that does equal 9. Let's do another number. How about, what if I had to do 22? All right, well, 7 goes into 22 3 times. That gives me 21. I have 1 left over. So it can be written as the numeral 3, 1. And again, to check it, I'm going to come down here. Want to check it. 3 times 7 to the first plus 1 times 7 to the 0, which is 1. So I get 21 plus 1. That's 22. Okay. And we're going to do one more. We're going to do the number 12. So 12. How would you write 12 in base 7? So again, how many times will 7 go into 12? It'll go in there once, and it leaves you with a remainder of 5. So 12 in base 7 is written as 1, 5. Okay, so let's come on over here and do the question at hand. Again, I'm going to rewrite it a little bit bigger so I can see which numbers are lined up. So 1, 5, 4, 3, 2, and then I have 6, 5, 0, 4. Okay, so let me start adding them. So 2 plus 4 is a 6. That's allowed. No problem with that one because it's less than a 7. The next number, 3 plus 0, that's a 3. That's also a keeper. No problem with that one. The issue is with the next number. Now I have 9. I have 4 plus 5, which is a 9. And again, remember we said, nope, can't use a 9. Cannot use a 9. So how do I write that in base 7? So 7 goes into 9 once. So I'm going to carry 1, and the remainder is 2. So I leave a 2 here. Now I go back over here. So I've got 1 plus 5 plus 6. That's a 12. I can't have a 12, right? So how do I get rid of the 12? So I said, all right, well, 12. How many 7 will go into 12 once? I'm going to carry 1. The remainder is 5. So keep the 5, carry the 1. And now my last column, I have 1 plus 1, which is a 2. And I can keep that one. So my final answer will be 2, 5, 2, 3, 6. And this is in base 7.